Kia ora, here's another video from this year's Level 3 Calculus papers. I've picked out a complex numbers one now, and I think this is an excellence question. I think it's a reasonably easy excellence question, definitely compared to the integration one that I did earlier tonight. So we're told that the argument arg of d plus 6i over 1 minus di is pi on 4, and we have to find the possible values of d, and d is a real constant. So what we have to be careful of with these problems is that when we get to the end and we've found possible values of d, that they do give us an arg of pi on 4 and not the arg of something else. So what we're looking for is that if the argument of a complex number, oh, there's my pen gone. Hang on, sorry guys. So if I've got arg of z is equal to pi on 4, that means that I want to be on this 45-degree line there, right? Very bad drawing, but the idea is that the real and the imaginary parts will be equal. And once you remember that, then the problem's pretty straightforward. Where we don't want to be, though, is we don't want to be back down here because these complex numbers don't have an arg of pi on 4, so that's the pi on 4 is there. If I'm back here, then they have an arg of negative 3 pi on 4 if I'm back here. So it's just something to watch out for with these kinds of problems. It actually turns out not to be a problem at all in this case. Right, so let's have a look at what d plus 6i over 1 minus di is. So let's just start out by saying, well, we've got d plus 6i over 1 minus di. We're trying to find the values of d. It's usually a good idea to multiply by the conjugate over the conjugate so that we can get our complex number into straightforward a plus bi form. So when we work this through in the denominator, first of all, we get 1 minus d squared I squared, so 1 plus d squared. And then in the numerator, we have d plus 6i plus 6. Whoops, going too fast. Just a second. Just get rid of that. So d plus 6i plus d squared I minus 6d. And I'm going to clean that up, and it will give me negative 5d plus 6 plus d squared I all over 1 plus d squared. And it's good to split that up into the two parts. So we get negative 5d over 1 plus d squared plus 6 plus d squared over 1 plus d squared I. Right, so remember, we want to have the real and the imaginary parts be equal, and we need them to be positive. So for arg of z equals pi on 4, we have the real part is equal to the imaginary part, and we have both of those be strictly positive so that we're in the first quadrant. So what that means is I can just set negative 5d over 1 plus d squared is equal to 6 plus d squared over 1 plus d squared. We'll work that through and see what values of d we get. I get negative 5d is equal to 6 plus d squared. So it's a straightforward quadratic. D squared plus 5d plus 6 is equal to 0. Factorising gives me two values of d. D is equal to negative 2, or d is equal to negative 3. So let's put those back into the very start of the question and just check that it all flows through. I know some of you are using graphics calculators to do this. I'm just going to do this by hand using my brain. But remember, go back to the question and just see what we had to show. We had to find d plus 6i over 1 minus di. We had to find the argument and show that it's pi on 4. So let's quickly do the case for d equals negative 2. So d plus 6i over 1 minus di gives me negative 2 plus 6i over 1 minus negative 2i, so 1 plus 2i, timesing by the conjugate over the conjugate gives me 1 plus 4 in the denominator, and negative 2 plus 6i plus 4i minus 12i squared, so plus 12. That works out to a very nice 10 over 5 plus 10 over 5i which is 2 plus 2i, which is fantastic because that complex number is sitting there. And we can see just from looking that the argument is pi on 4. Now, when we do the same thing, I won't go through all the algebra, but you can do the same thing to check for yourself. When d is -3, we end up getting 15 plus 15i over 10. So what's that? 3 over 2 plus 3 over 2i. So it's a point here. So both of them satisfy the condition. So I get 2 values of d for that answer. Again, haven't checked it with the schedule. If I'm wrong, please tell me, but tell me nicely. And if you've got questions that you'd like me to move up the queue from the level 3 papers, just leave me a comment here or send me an email. Thanks for watching.